fight for survival, it pays to be well armed. Life is not for the weak or the defenseless. It is a brutal contest, fought afresh each generation. But as well as the obvious weapons, the hardware of battle, animals are at war using state-of-the-art software. Welcome to the intelligence war, a hidden battleground of information processing, where victories turn on split-second computation, where strength can be defeated by strategy. Where animals triumph, not with firepower, but with brain power. East Africa, cradle of humanity, and still home to an ape that thrives not just through brawn, but by using its brain. The chimpanzee, though mostly a fruit eater, is a vegetarian Dr. Jekyll disguising a carnivorous Mr. Hyde. But getting meat presents a problem. Shaped through generations of evolution for eating fruit, chimps just aren't equipped with the claws, the camouflage, or the lightning speed for hunting. They must depend on other qualities. The target is a group of colobus monkeys, always alert and far more nimble round the treetops. But this is the story of survival of the smartest, not the fastest. Quietly, the chimps size up the situation. There are plenty of youngsters, easier prey. And the monkeys are in a tight corner with few ways out. If they can block the escapes, the hunters might seize a fleeing monkey. It's all a matter of strategy. The chimp's screams panic the monkeys. High up, the colobus are safe, but in the confusion, some of them break ranks. The chimps are waiting. Action replay shows the chimp fake towards the monkey above him, then switch to grab an unsuspecting bystander below. By using their brains, Chimps can make up for their limited speed and weaponry. Though only part-time predators, they can still outperform specialist killers. When they bother to hunt, chimps are twice as successful as lions. Intelligence is their hidden weapon. But if brains are such a winning formula, why aren't all animals armed with supercomputers? With huge variation in brain power across the animal kingdom, why do so many species have the budget model? It's a simple matter of economics. Nerve cells, which make up brains, are a colossal investment. And it's not just a matter of growing them. Their running costs are staggering. Just sitting on standby, nerve cells burn up fuel, staying primed and ready for action. They guzzle 20 times more energy than muscle and never rest. In a world of limited resources and ruthless competition, it just doesn't pay to have surplus brain power. In fact, many creatures thrive without a brain at all. Jellyfish are on the move. Each morning, sunlight guides them to the surface and into contact with the plankton they feed on. These commuters don't need brains, but they do need flawless coordination. The beat of the jellyfish bell is triggered by electrical pulses, firing at over 50 miles an hour along specialized communication lines, the nerve network. With minimal information, jellyfish can home in on plankton. But to hunt down active prey, animals need to gather more intelligence. Around 500 million years ago, there was a critical leap forward. Predators appeared that were armed with a new weapon. In its head, the land flatworm has a brain, admittedly composed of only a few hundred nerve cells. This tiny but sensitive computer leads it through the forest, reacting to sunlight, warmth, humidity, and gravity, and to a multitude of odors that may betray its prey. Compared to the jellyfish, the flatworm is swamped with incoming data. Its brain is there to weigh this information and make the executive decisions that keep it on track. Earthworms had better beware. A contact killer, the flatworm oozes chemicals onto its prey. For the earthworm, it's a slow dissolving death. Over millions of years, such primitive struggles have developed into more elaborate contests. For the adversaries, the advantages of smarter brains are always weighed against their greater costs. Outback Australia, and a mud wasp is preparing her family's defenses. Her egg chamber is underground. Above it, she builds an entrance tube, made to an exact blueprint. At a height of 1 body length, she turns the tube through a prescribed angle, then forms a precisely shaped flange. Onto this, she builds a large bell, measured to the nearest millimeter. Its size is critical for its defensive role, but so too is its texture. Though rough on the outside, the inside is polished smooth. The funnel has a specific purpose: to thwart the cuckoo wasp, an opportunist looking to plant her own eggs in others' nests. The slippery funnel keeps her out. Much larger than her enemy, the mud wasp can climb in. Her ingenious design triumphs. But the brain behind it is a blind computer, a machine that executes a list of instructions with no concept of what it's doing. Though economical, such a visionless machine has a flaw. Throw it off its normal course, and it's stumped. A buried tube should be easy to fix. The hard part is understanding there's a problem. After a brief pause, it's business as usual, the routine unchanged. An hour later, and the result is a shortened funnel, its entrance too low to add the crucial bell. The mud wasp's brain is a miracle of precise programming. But on this occasion, her robotic inflexibility has opened the door to her enemy. Fixed programs are wired into every brain. They may be inflexible, but such routines are the cheapest way to tackle many problems. Like the mud wasp, Mother Goose is a mindful parent. Should a precious egg roll out from the nest, she perceives the problem and responds intelligently. Or so it seems. But like the mud wasp, the goose's brain takes a shortcut and operates by a simple rule of thumb. If it's smooth and near the nest, it must be an egg. A goose's powers of discrimination are surprisingly vague. An egg needn't be white, or even egg-shaped. In her eyes, even a wooden cube can pass for an egg. Her Her simplified concept of an egg makes perfect sense. More elaborate, foolproof recognition would just be a waste of resources, of energy that's better used raising more young. Her undiscerning outlook ensures that a real egg is never ignored, even if a few mistakes are made along the way. But there's one bird where the stakes are higher. In the ostrich, the recognition software has had to improve. Here, females set up a communal nest. At first, the self-appointed caretaker welcomes visitors, who each add an egg to the clutch before moving on. A large brood raised under one roof will gain safety in numbers. But as the eggs steadily pile up to 25 or more, it begins to look like the caretaker is everyone's fool. With her workload mounting, new arrivals get a hostile reception. Any more eggs, and she won't be able to cover them all. Determined visitors, though, won't be turned away. Enough is enough. Letting off steam seems to clear the caretaker's mind for some cool-headed calculation. A goose would be in a real flap by now, but not the ostrich. This is egg overload, and it's time to concentrate on her own. Astonishingly, she can recognize each one. No fool, she carefully tucks her eggs safely into the middle before removing some of the surplus. Tiny surface pores vary in pattern between eggs, and this may allow the sharp-eyed ostrich to discriminate. However she does it, it's a death sentence for evicted eggs. The better she is at picking out her own eggs, the more young she produces. Her enhanced brain power pays off in breeding success. But in a world of complex challenges, a refined routine is not always enough. To compete, animals must also be flexible. The power to learn may be the ultimate survival tool. Sophisticated examples exist in our own backyards, even in the brains of insects. In the last 2 weeks of its life, a honeybee graduates from hive duties and emerges for the first time into the outside world. Its mission, to bring food to the colony, seems simple enough. Yet a bee faces a bewildering challenge. A confusing variety of open flowers, each producing nectar only for brief periods, and at times of day that vary from one species to the next. Never was the daily shopping trip so complicated. And with just 2 weeks to live, a budding forager must learn fast. Amazingly, the brain of a honeybee expands with age. As it matures into a forager, an extra 160,000 brain cells are added in preparation for the job ahead. Cracking the flower schedule requires a precise sense of time, and it's no coincidence that bees can read the sun's position to within a few degrees, equivalent to the passage of just 18 minutes. The trick, of course, is to match the flowers to the hours. A rookie forager is bound to make some bad calls. But trial and error is the essence of its strategy, and sooner or later, it gets lucky. With the sweet hit of nectar, its brain starts to forge a link between the flower and the time. Quite literally, a vital connection is made. Time, measured by the sun's position, is relayed to the brain throughout the day. Only when this coincides with incoming nectar signals does the junction take note and chemically set itself. Day 2, at the same time, and it doesn't matter where the bee is, the nerves automatically send a memo to visit the same flower. Just one successful nectar hit is enough to connect flower and time. Rapidly, the bee builds up its flower diary, with allotted visiting times for each species. A quick check on the sun's position, and a bee knows precisely which flowers are open for business. The ability to connect events, to use one thing to predict another, transforms an animal from a simple robot into a flexible learning machine. But sometimes there are no simple connections to be made, and no time for trial and error. Nature is notoriously unpredictable. For an African elephant with a lifespan of 70 years, coping with unexpected drought is an occupational hazard. When regular water holes dry up, these thirsty animals are forced to move on into less familiar terrain. There's no place here for the apprentice forager. These elephants need precise coordinates, and there's no time to lose. Elephants do have an extravagant sense of smell. They can detect minute traces of water in the earth and on the breeze. But if the water's downwind, that's of little use. To survive such a crisis, the entire herd may depend not on their noses, but on the memory of the oldest female. She alone may know where to look for water, and the key lies in a specialized part of her massive 11-pound brain, the hippocampus. It contains a database of spatial memories, of mental maps built up over a lifetime. To pinpoint water, she doesn't rely on trial and error. Before taking another step, she scans her memory and tests the journey in her head. Elephants know where they're going, even in terrain they've not visited for decades. Their epic journeys are mapped out expeditions over ranges spanning thousands of square miles. Drought is a fact of life. So for these thirsty giants, such memory is a critical survival tool. An elephant, even for its size, has an unusually big brain. It needs it to navigate in an uncertain world. But elephants also face another equally unpredictable and far more subtle challenge. They need to negotiate an ever-changing social landscape. It is the varied and complex demands of living with others that have led to the greatest advances in brain power. Africa's Kalahari Desert. Large or small, the brainiest creatures are the ones that live together in close-knit groups. The social meerkat has evolved a brain far bigger than you'd expect for an animal its size. The extra brain power is a huge advantage in a social environment where there are constant opportunities to learn. Just by watching their elders, the pups can pick up vital survival skills. Meerkats have lots to learn about the world, but much of it is quickly mastered. Figure out how to kill a scorpion once, and the same technique works every time. In contrast, fellow meerkats are much less predictable. Without warning, yesterday's playmate is today's thief. If there's one thing a meerkat can never quite be sure about, it's another meerkat. In the rough and tumble of group life, where food is stolen and bodies trampled, the threat of conflict is never far away. Social animals have larger brains, not just so they can learn from each other, but because they must learn to live with each other. Social awareness relies on recognizing and remembering individuals. Play fighting gives the pups a chance to develop these skills, and also helps to establish the pecking order. As adults, meerkats rarely come to blows. Social harmony is no idle luxury. Meerkats depend on close teamwork for their survival. In families like meerkats, helping each other comes naturally. But in other groups, where strangers mix, animals must have a more calculating attitude. In the hollow of a dead tree, just such a mixed group is stirring. In this society, help is more widely exchanged. It extends to special friends, beyond the ties of blood. Such friends can become long-term allies, and they renew their bonds through mutual grooming. Friends hang out together, but they also share the roost with other, more casual acquaintances. Their grooming finished, the bats head out to feed. And these bats are vampires. Scalpel teeth slit the skin, already numbed by a strong anesthetic in the bat's saliva. The victim feels nothing, allowing the bat to feed freely. As it gets to work, the vampire's stomach stretches to accommodate a massive helping. It can drink enough blood to last 2 days. But if it looks easy, think again. This is a high-risk way to make a living, and demands more than simple stealth and sharp teeth. If it fails to feed, a vampire quickly starves. 2 hungry nights in a row, and its life is on the line. It's time for quick thinking. Its only hope now is to find another bat prepared to share some of its spare blood. The problem is, why should any other bat cough up? The starving vampire begs for food. But it's rejected. It needs to find a friend, a grooming partner. To survive, it has to remember which of these roost mates it has helped previously. At last, it finds a partner. Inserting its tongue into its friend's mouth, the starving bat is allowed to drink regurgitated blood from a bat who owes it a favor. It's a life-saving act that will be remembered by donor and recipient alike. This sharing makes a precarious lifestyle more secure, but it relies on vampires having the brains to keep score. Only by taking care to count favors can bats know who to turn to and who to ignore. The blood bonds among vampires foreshadow more intricate social arrangements of animals more closely related to us. Macaque monkeys in the forests of Sri Lanka. Coalitions dominate daily life. Even the infants cultivate friends and soon learn who they can count on. Networking is an obsession. This is no place for the socially inept. Macaque society can be violent, and scarred faces tell a story of savage infighting. When trouble erupts, it helps to have friends. Group life would be hell without allies for support. The most powerful animals can relax. Above all, they have first pick of any females that come into heat. This female, though, has other ideas. She's giving the eye to a young Romeo. But he's not yet the boss, so they need to watch out. The dominant male rests up a tree, unaware of the clandestine courtship unfolding below. The rendezvous is on. The boss may be off guard, but his spies are out. They've been spotted, and the alarm is raised. For social animals like monkeys, the game is not purely a physical contest. It's a battle of wits, fought with brains as much as muscle. Living together is a constant balancing act between the urge to compete and the need to cooperate. Alliances hold macaque society together despite its violence. But the dangers of conflict have driven another monkey to evolve a remarkable method for avoiding tribal war. The gelada in the highlands of Ethiopia. Just like macaques, geladas form close bonds and rely on well-maintained social networks. But this huge gathering is not a single troop. It's a collection of smaller family groups, each one headed by a single, intimidating male. Under his protection are several females and their young. Their daily monkey business is much like the macaques. But there's one big difference. These monkeys are much less inclined to give each other a serious mauling. Life is no less competitive. On the contrary, Many family groups are drawn to the same prime grazing grounds, and competing for limited food and space does create dangerous tensions. And with such pumped-up males, the ingredients are here for the world's biggest brawl. But amidst a chorus of noise, brewing fights are somehow quickly diffused. Against all expectations, an unlikely harmony prevails in the gelada herds. It seems that these chattering monkeys have developed an unusual talent. Just listen to them. This volume of noise is unique among monkeys. It ebbs and flows continuously, like one gigantic conversation. Gentle and soothing, this strange hubbub helps keep the lid on simmering tensions. And most of the time, at least, everyone stays relaxed. But the social skills of monkeys have been eclipsed by others. Under the waves, a rival intelligence has been separately developing for 60 million years. Dolphins are also intensely social animals and tireless communicators too. Their societies are ruled every bit as much by friendships and alliances. But with dolphins, the scientific evidence is pointing to something new. The bottlenose dolphin has another card up its sleeve, something that sets it and us apart from most other species. This animal can see the world from another's point of view. It can make an imaginative leap into the mind of another being. To picture the world as another sees it and understands it is to open up new possibilities. Armed with this kind of insight, the actions and intentions of others become easier to read. Feelings, such as a calf's need for reassurance, can perhaps be imagined. And so too another's lack of knowledge and need of example. Such leaps of imagination are complex computations, but a dolphin can't compete without them. As far as we know, only one other group of animals has ever developed this ability. The power to contemplate the minds of others is a weapon also evolved by apes. In the social chess game, anticipating rivals is a crucial skill. Those who read others well can build themselves a winning power base. To fathom the minds of others, though, requires at least a glimpse of one's own thoughts and motives. It requires self-knowledge. Some form of conscious awareness. Whatever their thoughts, grooming is at the heart of chimpanzees' social life. As well as cementing lifelong friendships, this pleasurable activity secures short-term allies. But for these schemers, there are other ways to conduct politics. In the hands of a chimp, a prize piece of meat is more than a meal. Shrewdly handled, it's a gift that can buy future favors or seal a strategic partnership. Such conscious manipulation is commonplace for us. And just as in human society, more than simple brute strength is needed to stay at the top. When chimps bid for power, alliances make the difference. It's political muscle that really counts. Fights within the group are rarely lethal, but it's a different story when chimps run across outsiders. Strangers risk being murdered. Violence between groups may have driven the most extraordinary advance in brain power. Throughout our own evolution, we have, like chimps, clashed with rival groups. One thing that made us develop differently, though, was our invention of weapons. They made human conflict more dangerous. The survivors were those who could live together in bigger groups. But the bigger the group, the greater the skills needed to hold it together. In other primates, physical grooming is vital for bonding. In humans, it's been replaced by a much more efficient mechanism: conversation. Our speech is a masterpiece of biological evolution. Yet more than anything else, we use it for small talk, to forge and renew social bonds. Grooming has given way to gossip. Our chit-chat, though, is far from idle. It's a critical tool in the ultimate competition: courtship. Just as the peacock's tail attracts a hen, so over millions of years, ever larger and brighter human brains may have held more appeal for human partners. wit and wisdom, expressed through language and so demanding of brain power, may have less to do with survival and more to do with sex. Whatever the cause, our exceptionally complex brains are light years on from those first connecting nerve cells, the raw material which evolution has woven into such exquisitely complex calculating machines. Into brains that span a breathtaking range in size and ability, and which empower animals to make sense of their world. Behind every set of eyes is a state-of-the-art survival tool, a hidden weapon constantly at work, computing a winning course through life. And the story of brain power is an evolving journey, one whose twists and turns are hard to predict. But one thing is certain: evolution is thrifty and will continue to equip animals only with the brain power they really need. In a remarkable triumph of life, our species has scaled new intellectual heights, developing a conscious mind that can think beyond itself and imagine other realities. Our mind has a unique ability to contemplate its own fate and the fate of life itself.
To learn more about what you've seen on this nature program,